second, and then we will get started. All right, try to head your paper properly, please. All right. Like I said, I think today is very easy. Generally, the beginning of the chapter is very easy. I think I skipped section 3.1 because that was really easy. All right. So here we go. Okay, now what I want to do before we get started on here is I'm going to review the different types of angles. All right. Now, we're saying we have two parallel lines, and if you recall, this third line that intersects those two lines is called the transversal. All right. It's called the transversal. So now this right here, that's the symbol for parallel. So you have two parallel lines cut by a transversal. Now, there were relationships between the angles that are created by those parallel lines and that transversal. We had alternate interior, we had alternate exterior, we had corresponding, and we had consecutive interior, or sometimes known as same side, depending upon which geometry book. All right. So the first thing I want to do is I want to look up here and just review that. All right. So corresponding angles. So let's look at what I mean by corresponding angles. All right. This angle right here corresponds to this angle right here. All right. Now, how do I remember corresponding? I said corresponding means it's on the same side of the transversal and in the same relationship to the parallel lines. And what do I mean by that? This right here, I would refer to as the right side of the transversal on the top. Does everybody agree with that? So this is also the what? The right top. So those are corresponding. All right? Now, again, we don't have to write it all out. You can just pay attention. This angle here corresponds to this angle down here because that's on the right, but we say it's on the bottom. All right? So then you will notice that we have we would have a left top and what? Left top. All right? So these angles right here are considered corresponding. All right, just like the ones below that would also be considered corresponding. So we say they're on the what? Left bottom. All right, is everybody good with that? Now, what I want everybody to look at now, as I erase real quick, is if they are parallel, there's something that we remembered from 6th grade. What was true about all the corresponding angles? Remember? If the lines are parallel, the corresponding angles are equal. That is exactly correct. So if I said this right here was 50 degrees, then that's 50. That corresponds. Now we could easily figure out that this is 130. So then this would be what? And that would be 50, 130, 50, and 130. So does everybody see how the corresponding angles are congruent? Yes. Right? Then the next thing we want to do is we want to look at corresponding alternate interior angles. All right, so let's quickly define alternate. So interior, this is on the inside of the parallel lines. This is on the inside of the parallel lines. But they're on alternating sides of the transversal. Everybody hearing me? That's why they're called alternate interior. All right, and what's true about the alternate interior angles? They are congruent, or they are equal as well. So if I ask you about these two angles, those are also called what? Alternate interior angles, And if the lines are parallel, then those angles are what? Congruent. Everybody good with this? All right. Now we will discuss alternate exterior angles. Same principle, instead of being in the interior, now on the what?
Exterior.
Exterior of the parallel lines. So these two now are alternate what? Exterior. All right. And now the other one, this and this, those are also what? Alternate exterior angles. So again, we've just discussed corresponding. We've just discussed alternate interior and alternate exterior. And now we have one more to go before I close this out.
So could you also find some of these vertical angles?
Yes, that's how we're going to prove that.
Okay.
We're going to prove those theorems using vertical angles. All right? Now what I want to do is the last one I have to discuss with you is called the same side interior. All right? Or consecutive interior. I like to call it consecutive interior. Those two angles are consecutive interior angles. Are those equal?
No.
No, they are always supplementary. That is exactly correct. And then the other consecutive interior angles is right there. And those are considered what? Supplementary also. All right, so again, this is the second time you've seen this. So it's really not that big of a deal. All right, corresponding angles, alternate interior, alternate exterior, and consecutive interior angles. Anybody have any questions? All right, now let's get to the problems. All right, and 1 through 19, so let's just go through these real quick. It says in the figure, angle 1 is 94 degrees. So here we go. And you can just kind of watch. Angle 1 is 94. Now, before I even answer the other questions, I would just go ahead and fill the rest of them out. All right? If that's 94, what is angle 2? 86. 86. Angle 3? 94. And 86. Yeah, guys, that's very simple. Very simple. There are lots of ways you can deal with that and check that. All right? Now, the questions. What would be the measure of angle 3? 94 degrees. Angle 5? 94 degrees. And angle 4? 86 degrees. Everybody see how simple that is, right? All right, now angle 4 is 101. So once again, I just go to angle 4, 101. So that means angle 2 is what? 101. Angle 1 would be 3, 5, 7, 6, and 8. Yeah, you guys, that's just very easy. All right, what I always try to tell kids or remind kids is that all acute angles are what? Equal, and all obtuse angles are going to be what? Equal. Everybody get on that? All right. And so now what do? We just look over here and say they wanted 6, 7, and 5. So what's 6? 101. 7, 79 degrees, and angle 6. Or I'm sorry, angle 5. Thank you, 79 degrees. Make sure you put a little degree mark.
Are we doing all of them or just all of them?
I think we're doing all of them.
Yeah.
Right? Let me make sure. Yeah. On what other page? Oh. Maybe. No, all of them. I think. Let's just do all of them. It's not that hard. All right, now let's take a look at number 7. All right, it says in the diagram, the guardrail is parallel to the surface of the roadway, and the vertical supports are parallel to each other. Right? Find the measure of angle 2, 3, and 4. All right? That's not that bad, right? So angle 2 would be what? 93 degrees. All right? Angle 2 is 93 degrees. Now, keep in mind, guys, that this right here this right here is one, or these two lines are what?
Parallel.
Those are parallel, right? So this is your transversal here, all right? And now we have, these are parallel over here too. Does everybody agree with that? So if this is 93 over here, this right here is going to be what? And this right here is? And this right here is? So angle 4 would be supplement to 93, which would make it what? 87. So angle 4 is 87 degrees. Everybody see how I looked at that, right? Now, if this angle right here is 93, angle 3 is on the same side. All right, so it's called consecutive interior. And consecutive interiors, we said, were what? Supplementary. Could I agree with that? So then angle 3 would be what?
87.
Angle 3 would also be what? 87 degrees. No, I just don't think that's that hard. All right. Now look, guys, I've already done the first 9 questions of your homework, so hopefully you're working with me. I really don't care if you just write down the answers. That doesn't bother me. All right? Just make sure you know how we're getting those answers. Follow along with me. All right? Now we just have to do some algebra here, but these problems should be pretty easy for you. X should be what? 125. Is everybody happy with that? And then Y is what? 125. Now, a lot of times I just say, is it obtuse or acute? Everybody see that?
Oh, yeah.
Right? That's why it's easier to, in my opinion. They're not going to say the angle, draw an obtuse angle and tell you it's 10 degrees. All right? I've never seen them do that. Okay, so let's identify. What are those two angles here? What are these angles called? Alternate exterior. And they are what? Equal. So X would be, you should be able to just tell me 114. You freak out your math teachers next year when you say 114 degrees. They'll say, show your work. You know, it'll be kind of annoying, right? You guys, if you can't solve a one-step equation, we're in trouble. All right, so that's 114 degrees. Anybody have any objections? Now, technically, X is not really 114 degrees. Does everybody agree with that? I want to make sure I'm technically correct.
Oh.
It's just 114, right?
Yeah.
Right, because X is a value. All right, X just is a number that goes in there. All right, so over here. Now, I'm assuming 2x minus 15 is referring to this angle right here, and x plus 55 is talking about that. So they are what? Alternate interior, so they are what? Equal. So we could say 2x minus 15 is equal to x plus 55, and so now we can say x is 70. Now I really should go back and read the directions because it might say what is the angle. It says find the value of the variables. All right, so that's all we have. And if you had to explain your reasoning, you would just simply say they're what? Alternate interior. Are they agreeing with that? All right. Now what I want to do, because I think this is so easy, I almost was going to skip this, but I wanted to review that. Do I really care about the postulates or theorems? No. So let's just move forward on this. Nothing difficult. All right, let's jump on 27 for a quick second. All right, let's look at 27. All right. So what equation could I write for 27? Someone tell me. Good job. What?
3y plus 44 equals 96.
3y plus 44. Now, that would be true if it was a parallelogram. That'd be true if it's a parallelogram. But look right here, though. This is better for you. Somebody tell me what's true about those two? They're supplementary, right? Now, I personally think it's hard unless you do what? I like to tell kids, to me, sometimes it's easier just to do what? Extend those, right? Extend those. Does everybody see what I'm doing? And that way it's easier to actually physically see what they're talking about. You with me on this? These two things that I just drew are the what? Transversals. You with me? So sometimes, now watch, I'm going to show you what I think is important. Sometimes it will help you in the future if you do this. Watch. Now it's easier to tell, in my opinion. Does everybody see that? Right? Sometimes all those lines interfere with my ability to see what's two angles are congruent or what's supplementary. Does everybody agree with that? So sometimes if you have to wipe them out, it's easier to see that those are what? Supplementary. Does everybody agree? All right. So now, same principle. If I wanted to do that, I would wipe these out and say what's true about those two. They're supplementary. Everybody good with that? All right. So now, I feel good about that now. Same thing down here, right? If you need to extend those things out, I don't think that's going to be a problem for you. All right. Now, the most important thing I now saw was this little proof for number 30, so we're going to talk about that. All right. Now, if you want, you can kind of really just kind of pay attention here, and let's see what's going on. All right. Now, it says copy and complete the proof. It says, given that angle N, or I'm sorry, given that line M and N are parallel, and L is a transversal, prove 1 and 2 are supplementary, and prove 3 and 4 are supplementary. I thought it was kind of obvious, right? But we're going to prove that now. All right, so again, kind of an important proof. All right, here we go.
Given, or should I do
Yeah, no, just tell me what the first one is.
Okay, M and N are parallel.
Yes, exactly right, guys. Exactly right. I'm not expecting that to be too big a deal for you. Let's see if I can do that. Probably won't be able to squeeze it in. Ooh. Yeah, I don't want to do that. All right. So we just have to write that in there. All right. And again, don't be too lazy now. All right. Because again, I think the hardest part is the proofs. So M is parallel to N, and L is a transversal. Okay. Now, for B, why do angle 1 and 3 form a linear pair? What are we going to say for that? Remember? What are you thinking?
Linear pair postulate.
Yeah, you know, there's a couple things here. Remember, I think, didn't we say the linear pair postulate means that they are supplementary? I think that's what that means. But that's, like I said, that's a common mistake, and I guess what I'm trying to say is sometimes you make little mistakes like that. Now, if they tell you it's a linear pair, that has to be the what? That has to be the definition. It's kind of like, you know, if they tell you something bisects, right? Then that's going to be kind of the definition of bisect. So here, if angle 1 or it says angle 1 and 3 form a linear pair. Well, how do we know they form a linear pair? Because that's what the definition of a linear pair is, right? Two angles that are that share a ray, which is called adjacent angles, but they also form a line. Is everybody with me on that? So here we want to say that's just the definition of a linear pair. Now, if the two angles form a linear pair, then they are supplementary. That's when we said it was the what? Yeah, I think that's what the linear pair postulate was. All right? If they form a linear pair, then they are supplementary. All right? So, angle 1 plus angle 3 equals 180 degrees. And what? Angle 2 plus angle 4 equals 180 degrees. Everybody with me on this? All right. And if you wanted to, you could put, instead of writing all that, if it was blank, the linear pair postulate. The linear pair postulate. Now, why is angle 1 congruent to angle 4 and angle 2 congruent to angle 3? So let's look at this. Look at this. Let's figure out what they're talking about right here. Angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Those are what? Yes. Now listen, I should go back. They should have mentioned this, and it's probably my fault too, so I'm going to go back and discuss this. This is alternate interior angles are congruent. And that actually is a theorem. And then we're going to talk about it in a few minutes, because I'm going to backtrack a little bit because I forgot to say something. So that's alternate interior angles. Do you agree with that? And then once things are congruent, you can say that they are what? They're equal, right? So now, if angle what? Because I'm looking up here now, I'm trying to do angle 1 and what? Angle 1 and 2, right? So if 1 is congruent to 4 and 2 is congruent to 3, I can now say that what? Yes, angle 1 and angle 2 are what? Supplementary. And angle 3 and angle 4 are supplementary by what? Yeah, aren't we just doing a substitution on that, right? Substitution. Because why? Just to make sure you're seeing it. I'm going to highlight this right here, right? 1 and 3 right here. 1 is congruent. So where does it say? Yes, here we go. Everybody see this? 2 is congruent to 3. So I can replace 3 with what? 2. Everybody good on that? So 1 and 3 form a linear pair, so 1 and 2 form a linear pair. Yeah, I'm not sure exactly. I think I would see that a little bit different. All right, so let me try to show you something. Now, obviously, this is right out of the book. All right, but that's what I'm saying. Sometimes I see things differently, and I'm seeing things a little bit different. Right? I would have said 1 and 3 form a linear pair, 2 and 4 form a linear pair. And if 1 and 2 are supplementary and 3 and 4 are supplementary, that's what I should have written right here. Hold up 1 second, guys. Yeah, I kind of messed that up a little bit. Look, instead of angle 1 and 3 is equal to 180, is equal to 180, and angle 2 and 4 is equal to 180, we could write there also what? Angle 1 and 3 are supplementary. Is everybody with me? Now, look, let me just change this real quick. That's why I was having a little issue. Look right here, guys, and that's my fault. I'm just going to erase this part. Angle 1 and 3 are what? Are supplementary. Then it makes better sense when you make the substitution. Does everybody see that? 1 and 3 are supplementary. But then you would say what? 2 and 4 are supplementary. Does everybody agree with that? Now, why do I like that better? Because now I can just make the substitution directly into this statement, and that's what this statement says up here. All right, so listen, guys. Does everybody understand what I'm saying, right? Right? Instead of saying that they were equal to 180, I should have just said they are what? Supplementary. Because that's what I'm trying to prove up here. Everybody good with that? All right. So now what I want to do is I want to go down and I want to try to show you something now. All right. So in this section, there is something called the corresponding angles are what? Are congruent. Corresponding angles are congruent. And that is a what? That is a postulate because that's something you have to what? That's something you have to accept is true, just based off observation. Is everybody hearing me? All right, so now I'm going to draw something up here. And then I'm going to tell you we're going to prove something real quick. All right. So if I say, for example, angle 1 and angle 2, they are congruent because of the corresponding angle what? Postulate. Hear me? Corresponding angle postulate. Now this is why I had the biggest trouble with my geometry class, and I always can remember arguing with her over this information. I am now going to prove that the alternate interior angles are congruent based on the corresponding angle what? Postulate. All right, is everybody with me on this? So we are going to now prove, and we're just gonna go ahead and do that right now together as a class. So here we go. So I'm trying to prove to you, I'm trying to prove that angle 2 is congruent to angle 3. Is everybody hearing me? All right, and I am proving to you that alternate interior angles are what? Congruent. That's what I'm doing. All right, so here we go. With that, it's very, very simple, so I'm sure it won't take much time at all. All right, so watch. Real simple. All right, in here, this is my statement, and these are my what? Reasons. Okay, so basically, you have given that the lines in the transversal are there, just like before. So bear with me. So number 1, we'd have, if this is L and this is M, you would say line L is parallel to M and LMN, and line N is a what? Transversal. All right, and that is what? That's given. All right, so here we go. Step number 2. Angle 1 is congruent to angle 2. Why is that? No. Think for yourself. Corresponding angle postulate. All right, here we go. Corresponding angle postulate. All right, we only know that because it's based off of what? Observation. Every time I draw parallel lines with a transversal, those angles are always equal. It's a postulate. All right. Now, what can I say? So now what I have is that angle 1 is congruent to angle 2. Now tell me, Walker, what could I do next?
Maybe you could say that angle 1 and angle 3 are vertical angles.
That's 100% correct. All right. So we would now say that what? Angle 1 is congruent to angle 3. And we say that's a vertical angle theorem because we proved that. Vertical angle theorem. Did I get on that? And then?
Does the order of 2 and 3 matter? Like, could you put 1 is congruent to 3 and 4?
You can do that. All right? Yeah, the order most of the time doesn't matter. So I see that, right? So now what's true? Substitution. So what am I going to say? What? Angle 2 is congruent to, and that is a substitution. So everybody see how simple that was, right?
Yeah.
Now, the thing I tried to impress upon you was that the corresponding angle is a what? Corresponding angles are equal by a what, though? By a postulate. But the alternate interior angles can be proven by a what? By a proof. All right. Now, again, why is that such a big deal? All right. Because I based a proof off an observation. So you understand what I'm trying to tell you. In other words, there is no way for me to prove that those two angles are equal. In other words, I can't prove that angle 1 is congruent to angle 2. You with me? And so to me, it was a little strange that I'm using something I can't prove is true to prove that something else is what?
True.
Does everybody agree with that?
Yeah.
All right, so it's a little shaky in my opinion. All right, so again, that's not a big deal, but I really wanted to stress today corresponding angle postulates. And if I wanted to prove alternate interior angles, if I wanted to prove consecutive interior angles, alternate exterior angles, those are all going to be considered what? Theorems. And to prove those, you're going to use the what? Corresponding angle what? Postulate. Is everybody with me on that? All right, yes, go.
For number 38 and 39.
All right, hold up. Let me find 38 and 39. All right, let me see what we're doing here. 38. Oh, yeah. I want you to try that. I think you can do that. And if you don't know what an auxiliary line is, you can look that up. All right, that's something I want you to do. Now, again, 38 and 39, I have been on the SAT before. All right, that's another reason why it's important. All right. Now, I don't really think we're having too many other issues. All right, I think that's good for today. You guys should be able to zip through that pretty easily. All right, get busy, yes. I'll put it right here. This is what I want you to do. 1 through 19, 24 through 30, 38, 39. Get busy, get busy, get busy.